So I've made a few adjustments to this pyro burst source. As you can see, I turned this down in scale, as well as added some more of these guys in here. And if I middle mouse this right now, we are at about 1.8 million points. So around 2 million points is good. It's better to have more points here and then rasterize, as opposed to not enough points and then go to rasterize. So about 2 million is actually pretty good. To make the source volumes which feed into the pyro solver, let's use the volume rasterize attributes. If we plug that in and we say density, it'll take the density values on these points and turn them into volumes. Also, let's use the volume slice to see what we're doing. Now the goal here is to have about 300,000 voxels. About 300. It could be a little bit more, a little bit less, but that's typically a good range to be for most situations. So for the voxel size, let's start off by turning this down to 0.005 and our particle scale down to, or maybe 0.05 like that. And the particle scale here maybe to about 0.5. We might actually end up going up from this particle scale, so we'll bring this up a tad bit until we can see that we have the red defining a lot of our shape. So there we go. There's the red. And let's also change this filter size. Now you have to watch out on this filter size because if you bring this up quite a bit, it'll take that voxel count through the roof. So like right now we're at about 400,000. When we were down here, that was at about 100,000. So this minimum filter size makes a big difference. It basically blurs together the surrounding voxel values. So let's go right about there and we'll take our voxel size down even more. So maybe 0.03, something like that. Middle mouse, about 400,000. Take down this filter size a tad bit though. And we're now at about 375,000. So, looking through here, if we just scroll around, we can see that we're defining these shapes pretty well. And I've already set up this file cache so that we can cache out those fields. In this case, just density. And we'll save that out as a VDB. Once we do that, you should be able to see this play out like so. The viewport preview isn't going to be super awesome, but it should just, generally do the overall motion like that. Let's also take this up just a tad bit. I found with volumes that it's best to give it a little bit of extra breathing room because otherwise the collisions can snuff this out very easily. So I took this up by maybe let's say 0.1, and that should be enough padding to be sure that we're sourcing in everything. Inside the .NET, I have a very simple setup going on. We have a pyro solver, we have gravity, smoke object, and a gas resize fluid dynamic. Now, if you've never done pyro before, be sure to review my pyro lessons because this deserves its own explanation and study. Here's a quick rundown though of what I have. On the smoke object, right now we'll have a division size of 0.1 as we test things. On the pyro solver, I said use OpenCL. That tells it to use my GPU. Combustion, we don't want to worry about it because there's no fire. And likewise with the temperature stuff, we don't have temperature going on here. We don't want these upwards plumes of smoke really. We'll have other ways of getting upwards motion. We'll use our pieces to do that. But I don't want to use temperature in this situation. And then for, let's see, the gas resize fluid dynamic, this is set to delay by about 30 frames. I found that we have a pretty fast source going in, so it makes sense to only clamp down once we've gotten past that fast wave. So there you go. Nothing too crazy if you've done a bit of pyro before. Source volume, or volume source that is. Let's go ahead and bring in that density. So we'll say take the first input, plus icon. We are looking for density. That is a scalar value right there. We're going to add, and I'm going to turn up the scale to about 30. Now I also have gravity right here, and just for now, let's create a ground plane so that we can just see what's going on. So if I go forward a few frames, we should see a bunch of smoke just kind of, plopping down on the floor there. Looks beautiful, really. Okay, so there you go. We end up with this. We can do a whole lot better with these collisions though, and this time I want to use something different. I want to take an Sdf volume of our entire simulation and use that as a collision mesh for these volumes. Now I really shouldn't say it's going to be a mesh, it's going to be a collision field. So if I create another volume source here, we're going to source in, if I go to the top here, initialize collision. So that means the collision field, and that also means collision velocity. So let's talk about what these two things are trying to do. First of all, let's label this. So source density, and then we'll say source colliz. First thing we ought to do is create an Sdf volume of all the pieces thus far. So that means going way down here to this merge, where we basically have everything except for the packed instance pieces. And we're going to use this as our collision. So it's going to take a minute to think about this, but we end up with all these chunks right here. Let's create a null, and we'll say fractures out. Let's go to the very top here and create a object merge, and you guessed it, we're gonna go grab this guy, fractures out. Spacebar F to frame, second inputs. Now, SDF, or a VDB from polygons, that is. If we do that, we take an SDF volume, we cache this out, and we source that into the second input. That's going to be what we need for the collision field. So on this SDF, the voxel size, let's say that that's going to be 0.025. And it'll take a second to do this. It's okay if you have a fair bit of resolution on this. We'll end up sourcing in a lot of voxels, so it's all just kind of part of the game here. But we end up with this, and I think this is going to be enough for what we need. Now you'll notice that we have a bad piece right here. It appears that this particular piece is not a closed off piece of geometry. So we could just try to identify that one particular piece and fix that issue. So if we select this based on 3D connectivity, so I'm up here, select by group, group is 3D connectivity, right there, and we press delete, that should create a blast node. It'll create it way down here for some reason. And we could say delete non-selected, and then from here we can try to troubleshoot what's going on. Again, if there's any point along here where this is not totally closed off, it's going to cause an issue. And look at that right there. That's the problem. So this would probably be a very easy thing to fix here. If we do a polyfill like this, it's not going to like that. Let's try using a triangles. There we go. Now we've filled that in. We can also try using a fuse, but I think in this case we've closed this off just to double check this. VDB from polygons, and we can turn this up, so 0.02. And now we successfully have this piece all fixed up. Okay, so with that in mind, we blast that out, we fix it. Let's inverse that blast, and we'll just merge it back in with the rest. Simple as that. So take this guy, this, and we'll merge that. Once we have this merge, we'll go down here to the transform pieces. Let's make sure that everything still works with that. So go to frame 40 and back down to the merge. Should be good to go. And yes, we in fact are. So again, that goes all the way up here. Bring that in, VDB from polygons, and cache it out.